Well, welcome to this week's Tim's Take, and today we have a very special guest, Dr. Mark Cogsnoll, and he has a great story. He's been a tree geneticist, breeder for his entire career. Now he's officially retired from the University of Missouri as a research assistant professor, but you're adjunct, meaning they still draw on your knowledge.
Such as it is, yes.
That's right. Mm-hmm. And you've had an interesting career. And first of all, tell us what you've done both here and at Purdue.
Oh, boy.
Or Indiana, I should say.
Let's start with Indiana because that was when I was the youngest.
Now, wait, before we get started, you have a funny accent. You're not from Indiana or Missouri.
No and no.
Okay.
I'm from Massachusetts.
From Boston.
Just north of Boston. So
all we know about Massachusetts is Boston.
There's a lot more to it than that.
Is that right?
Yeah.
There's trees?
Oh, yeah, for sure. But that's another another day. Another one of these chapters.
All right. So let's talk about Indiana first.
Okay, so real quick, I'll try to be quick. Went to undergrad school in New England, went to graduate school in Mississippi. That's a little different than Massachusetts.
Yeah.
They start with M. That's about it. And anyway, got out of there and moved to Indiana. Why did I go there? Well, that's because there was a job there. And the job was based upon a forest genetics or tree improvement position that I was working with people at the state nursery system, similar to the George White Nursery in southern Missouri and down at Licking. Parallel work, and to produce all the seedlings for reforestation or afforestation for their customer base, whatever that customer base looks like, you have to grow them from seed. And some of those seeds, you cannot store them like you can grain crops for multiple years or multiple decades. You cannot store them for more than about 3 or 4 months. I'm talking acorns, I'm talking pecans, I'm talking walnuts, black walnuts. They are recalcitrant seeds. They have to have certain amounts of cold and very much they have to focus on a certain level of moisture content. And if you have this moisture content that falls below some threshold, they'll never germinate. So they're very fussy, so you can't store them long term from one year to the next. Examples of trees that would be orthodox seeds would be maples, ashes, sycamore, things like that.
That you can't store.
We can store those.
You can store those.
But you can't store the seeds, the big seeds, as in bur oak seeds, for example.
Oaks, hickories,
same story. So the result is you have to, and this is that suite of different recalcitrant seeds species. We're in high demand. I was there for 20 years in this position that I had. And so where do you get the seeds from? You hopefully find them from local, quote unquote, well adapted, to the point we knew what that word meant in those days, sources. And you had to produce seeds every year because the nursery produced seedlings every year. And so it was always a challenge. So that was my job, was to try to define where to get the seeds for these different tree species that the nursery system was producing.
Now, when you're talking about a native plant this way here, so you're going to throughout Indiana then and Missouri now.
Yes,
you're going to the seed source,
right?
And those are called what, landraces?
Oh, I guess we could go down there,
or
that road.
but they have a very.
I think adaptability within a species of whatever tree we're talking about. Well, it depends on so many different things. It depends on what traits you're interested in.
Sure.
And if you're looking at leafing out too early in the spring, well, that can cause damage to the resulting new spring growth. This is a problem in black walnuts, by the way. And the result would be that you'll have no seeds, because that's where the new flowers that produce the new seeds come from.
So if I took a black walnut,
for example,
from Mississippi,
yeah,
where you were at, and brought it up up to here or Indiana, there's a chance it wouldn't do well.
Correct. It would. I can give you an example in white oak.
Okay.
White oak is a very valuable timber species now, especially because of the demand for worldwide demand for its use in stave industries.
Wine and whiskey
wine
barrels.
and whiskey barrels, and here in Missouri, we produce more of such product than any place else on earth.
Really?
Yeah.
And they get shipped to Europe.
And it's shipped to Europe, it's shipped to South America, shipped to South Africa, and on and on. It's a very big business. I grew some seedlings from Mississippi, planted them in Indiana, and how did they do? The trees, they grew like rockets, really, really fast because they're used to growing in a long growing season. Because the latitude that they came from, guess what? The latitude is it's way down, quote unquote, way down south. So now the question is, they grew really fast, but did they ever produce a nut?
Really? No nuts.
Nope.
But they probably give you a good timber tree.
Absolutely, great timber tree. Great for staves.
So if you wanted just timber, you could do that.
Right. If you could import enough seeds from the right sources and further south. So the take home is a white oak or a black walnut. If you see one in black walnut, say, they grow in Massachusetts. Now, if you are the black walnuts that grow in Massachusetts and the black walnuts that grow in Indiana or Mississippi or Minnesota or Michigan, just because they all have the same botanical name, are they the same? And the question is, that's the point. And the answer is no. Some of them are crooked. Some of them are straight. Straight, if you're in the timber business, you want those nice straight timber, telephone pole type trees.
Like a ponderosa pine.
Exactly right. And can you find them? Yep. Do the seeds from those telephone pole type trees, do the seedlings derived from those seeds from that telephone pole type tree, do they grow straight too? Sure do. So it's a heritable trait.
Oh, good.
And it's a heritable trait whether you plant them in one end of the state or the other end of the state. The ones that are straight tend, that's the key phrase, to grow straight.
Because they're not pure. They don't breed pure.
Correct.
They're heterozygous.
They do not come true from seed. They do not self.
Okay.
Unlike winter wheat, for example, or soybeans, as far as I remember.
Right.
Once you fix the trait that you want within the genome of a soybean plant, for example, like Roundup Ready G, whatever, simply, and everything from then on, from generation to generation to generation. Oh yeah, by the way, they're orthodox seeds, so you can store them for how many decades?
True.
You know more about that than I do.
Exactly.
So the result is that they do come true from seed. Self plants do. Agronomic plants that you're familiar with, Tim. But in the world I live in, they are not.
So trees have to have another one to crossbreed.
Correct. Yes, particularly with oaks.
Okay.
But I think in the you can make it up to black walnuts. Sorry, I'm jumping around from one species to another. Do black walnuts self? Yes, they do. 3 to 5% of the time. Hooray!
Right.
Big deal.
So if I had just one black walnut, and I don't have any neighbors within a mile of me of another black walnut, I probably won't get any fruit.
You'll have flowers, certainly, and some of them may be selfed. It depends. We can get into the weeds here really quick in terms of the flowering habit and the flowering timeline on the calendar, that is, within a tree and between different trees, growing in a stand of an acre of walnut trees, for example, wild walnut trees. So also that Mississippi walnut may bloom a different time than our Missouri walnuts. That's the problem. So that could be an issue too. That's the problem. Yeah. Okay, that is the problem. Yeah. Okay. They're so out of phase with anything around them that they bloom so early, quote unquote, early, compared to the local stuff in the same geography. Should we be worried about within Missouri? Do we have enough variability? the variability. Pick a species that we've touched upon today so far.
Walnut or the white oak.
Is there variability? Again, let's talk about what traits are we interested in.
Okay.
But let's talk about adaptive traits. Adaptive traits meaning when do they flower? When do they start to grow in the spring, and when do they stop growing in the autumn? Okay, the season, the season length. Is there variation within the state of Missouri for that trait? Oh my.
Really?
Yes, to be sure. So, for example, real quick example from my time here in University of Missouri, one of the things of interest is coming from little old Massachusetts, which is really a small state on the map. Missouri is a very, very big place from my perspective. And if you live in Cape Girardeau, in one corner of the state, or you live in St. Joseph in the other corner of the state, and you are more familiar with the geography of the state than I ever will be, how long does it take you to get from one point to the other?
Oh, that's about a 7-hour drive.
7-hour drive in one state. Well, in 5 hours I could be in New York City, and in about 6 I could be in Montreal.
Oh, wow.
From where I grew up. So you get the idea.
Yes.
But my point for bringing this up is that the growing season, and again, relating to agronomic crops, I would assume we could have a parallel, description here. Cape Girardeau has a growing season of, you make up a number,
right,
versus St. Joe.
Sure.
And so one of the things that I was looking at in my time here, was to focus on what's the season length between the time, this is black walnut now, between the time the black walnut female blooms begin to do what they have to do to receive pollen, okay, versus the time when you can take the nut off the tree. It's mature. It's ready to. What's the variation? In some cases, you can produce a crop of nuts in 105 days. In other cases, you can produce another crop with a tree growing about 40 feet apart, one to another. One's a 105-day plant, one's a 165-day plant.
Oh, my goodness. 2 months.
And so guess what? If I was going to take my 165-day plant and put it up in St. Joe,
it may never make
it
anything.
may not go well.
Right. Okay.
So that's an example, a very tangible example of the inherent variation. And this is not just a one and done 1 year. This was over, I looked at this flowering thing 5 years in a row. And every single year they all behave the same. The early ones are early always, and the late ones are late always. So does that make a difference in terms of how you would deploy this short season tree versus a long season tree into an orchard setting? If you live in St. Joe, or
yes.
You get the idea.
So you're starting to rethink.
I was simply trying to get a handle on, if you will, what's the variation?
Yes.
We were working with, here in Missouri, I was charged with working with black walnut to develop, to domesticate a wild tree that is native, really important. We're not talking about Persian walnuts in California.
Right.
They come from Asia. And so then they have a very narrow genetic base to start with. But in Missouri, in black walnuts, the variation is staggeringly huge for whatever trait you want. What do you want? Do you want a short season plant, long season plant? It's can you find them? Oh yeah, it's as easy peasy. It's really simple. So,
and that's probably a great survival mechanism for the plant, for the species.
Indeed,
where we have a huge variation in maturity. That way we have late freezes, early freezes,
right,
that were protected. Yep. Also probably for the wildlife that utilizes those.
To be sure, yes.
It gives them a much longer period.
Right. And it gets into perhaps another orchard-based observation that might be of interest to some. When I went like this with my hand, I don't know if they can see that or not. When I go like this with my hand, when the walnut on a walnut tree, the fruit now is mature, how do you tell it's mature? Do you wait till they fall to the ground? No.
Oh, that's how we do.
No, you don't. what you do is when it's similar when you go to a grocery store this time of year. This is in last week of November. We're filming this. You go to the grocery store and you want to buy a pear. And as I would say at home, it would be a pear. But you get the idea. P-E-A-R. Okay? Yeah. Pear. One of those. And how do you tell when they're ripe? You squeeze them. You usually squeeze the neck of to put a little dent. That's when the fruit is ripe. That's when the edible nut kernels that we all want to eat, okay, that's when they are the most mature. You can leave them on there inside that husk, until they are black as your shirt, the fruit. And guess what color the nut meat's going to be?
Same.
About the color of your shirt.
Oh, okay.
Because it stains, it goes, the stain of the fruit as it degrades, as it matures,
sure,
it will stain the edible part that you want.
So when we pick them up off the ground, they're already probably starting to stain.
To be sure. Okay. And to optimize the value, frankly, the appeal of the kernels that you might want to eat, you pick them as early as you can. Once you can, just like picking a pear.
Can we just shake a walnut tree?
Shake the walnut trees, just like you shake pecans.
Sure.
Yeah.
So
excuse me.
That's interesting. I never thought about it that way. Go back a little bit to site. So Ozarks, very thin soils.
Oh, yeah.
These white oaks are growing, and I know there's some stave plants down there.
Yes.
We also have some in North Missouri, a little deeper soils. Same white oaks, but probably adapted a little differently.
Yeah. I would assume. Here in Missouri, I'm not a student of variation of white oak per se. I did that back in my old job, but the challenges of growing white oak in a forest au naturel, in a forest stand, it's not easy, and they're very. I'll use the word fussy plants. Not only, I'm not a soils guy. You'll have to get someone else on here to talk about soils, but they're very fussy in terms of their requirements for light availability.
Okay.
As a very young, this high, a very young tree, they need so much light, and if you don't give them enough, that's all they do. They get that big, and they'll never grow. They'll never take off, quote unquote. And so they have lots of. They grow slowly. They put a lot of energy into their root system first meaning for like 4 years, 5 years. And then eventually they'll start to pop. But along that timeline, you have issues for competition from other tree species, other woody vegetation, or just plain old quote unquote weeds, herbaceous material as well. And so it's hard to grow white oak reliably.
So should we be worried then that we are a great market source for white oak staves?
Yes, indeed.
Should we be worried that we're harvesting more than what we're starting?
Some people would respond that way. Yes, I think it's a case of on a local level, and you can define the word local as you need to. That would be potentially a fact. However, you can source white oak, which is it grows from Kansas to Maine, and this is, I think they source white oak logs for stave production. I think the number I heard was 26 different states.
Okay.
Huge geography.
Okay.
And so that's other people can speak more to this than
that
I
helps.
can.
But one of the things I thought about, the turn of the last century, the early 1900s,
right.
Southeast Missouri was full of white pine.
Yep.
And for about a 20-year period, tremendous industry. And now that's gone.
It's gone and
gone.
Yeah.
And grew back into hardwoods.
Right.
oak and hickory.
Yeah, these forest conditions, these turnovers occur based upon exploitation, for example, in the lake states back in the 1850s or 60s. Excuse me. Same thing in Massachusetts, but it just was a century earlier, or maybe 2 centuries before that. But they had that's the nature of it.
Well, you mentioned Massachusetts, and you told me last week or 2 weeks ago when we were talking that in the 1850s, Massachusetts was like 10% forest, but now it's 90?
Yep, 95.
So there's a big reforestation of New England, but is that same thing in Missouri too, isn't it?
Oh, I think the number of
not that big, but
yeah, I think again, I'm
you're stretching your limits.
I'm at a deficit here. I do know that I've heard many times from many places it's either 14.5 or 15 million acres of forested lands within the boundaries, the political boundaries of Missouri, which is huge,
right?
Staggeringly huge. And for me, that from where I'm from, way back when, that's mind-boggling.
But I've heard like Gene Garrett mentioned how the greening of Missouri, these old abandoned pastures in the Ozarks have become more and more green with trees now.
Yeah, with trees. So one last little factoid. When you think about black walnuts now, I'm sorry, I'm dwelling in that world too. What state has more black walnuts than any other state?
I bet Missouri.
Da-da-da. You're the winner.
All right.
By a whole lot.
Really?
Like a whole lot. It is, I think, the next state I think it's Kentucky. So it's not Indiana.
Right.
Because Indiana's so small compared to Missouri, area-wise. But anyway, the resources is for black walnut is very large, as well as for white oak. I mean, the people who make the stave factories, if you will, that are resident in Missouri, they're here for a reason.
Right.
So anyway.
So managing that resource will be important.
Oh, it has become a focus. It always has been, but it has become even more of a focus in the forestry community in terms of how do you regenerate successfully?
Yes.
How do you do it? And what are the prescriptions? And I think the take-home is it's not a one-size-fits-all. That's the problem.
Sure.
It's very site-specific. Wow. And so
in the Ozarks in the North Missouri or
to be sure,
or wherever.
Right,
and finally, before we close on this section, I just saw where Missouri is now is USDA Zone 6.
Oh yeah.
And that's changed.
That's shifted. Yeah.
Can our plant genetics keep up with this shift?
Oh yeah.
We're getting warmer. I think warmer nights, especially.
Right.
Seasons are getting a bit longer. That's the plants have to adapt to that.
Indeed. There's for the little bit of experience I've had with trees and their variation, the inherent variation that we can exploit, if you will. I use that word frequently in this context. Is the variation that we can take advantage of. Oh yeah, absolutely.
We take advantage of that.
Absolutely.
Okay.
Yeah. So.
Because we have that variation in the plants.
Because we're talking about a native tree, which has more stems in Missouri than any other state, and if you want to find something that would suit your purposes based upon the traits that you are interested in, you can find it.
Okay.
It just takes a little bit of work.
And the plants themselves will sort themselves out too.
Indeed, because just because they make up a number, a tree will produce 2,000 walnuts now. Black walnut seeds per year. How many seedlings are you going to get? Maybe half.
Right.
That will germinate. I mean, to produce a tree that's a foot tall. And then how many of those will still be there in 5 years?
Sure.
It won't be half. It'll be,
but it's the survivor of the fittest.
Indeed. It's a great mortality curve.
If the climate does change, they will adapt because they are native and have this huge genetic potential.
They have a great depth, I would argue.
All right.
Yep.
Well, thanks, Mark. This has been fascinating about the basics of some of our tree genetics and adaptations. And next we'll follow up with specifically what you have done with black walnut and other nut trees.
Okay.
All right. But this is it for this section of Tim's Take.